Alright, moving into worksheet A for chapter 9. So back into some calculus stuff here. So I'm going to go through these, try to go through these pretty quick for you. So on number 1, just doing an integral process, or you could say anti-differentiating. In any route, we want to put this thing into friendlier terms first. So first thing we would want to do is bring the x to the third up to the top, so that it looks like this. And now we would go through the integral process. So in these cases, it's just the opposite of doing a derivative. So now we add one to our exponent. So it would now become 4x to the negative second because we added one. Then you divide by the new exponent. So a little cleanup on that. And we're looking at negative 2x to the negative second. And then now this one was a definite integral because we're given some values. If it were not, remember that you would have to put your plus c right there. That's always a half a point off if you don't do that. So, but in this case, we're now evaluating it from 1 to 2. So this is where we do kind of the right side of this. We're now going from 1 to 2. So to move forward from there, we know we're plugging in the 2 first. I'm going to move this exponent back down below just because it's going to be easier to work with from there. So I got my negative 2 over x squared, so over 2 squared. And then from there I got my negative 2 over 1 squared. So that's the way I would set it up. Always important on a test to show your work, because if you get the answer wrong, as always, this is kind of your backup points. So always show work where you can. So negative 2 over 4, which is negative 1/2. Minus negative 2 over 1, which is negative 2. So we got that double negative right there. So 2 minus 1/2 would give you 1.5, or you could say 3/2. So either way. So that would be our definite integral for that one. So moving over to number 2, pretty much the same thing. This one's should be maybe even a little easier because the x to the third is starting on top, so we get the positive exponent. So if we go right into our integral process on this, we're going to add one to that exponent and then divide by that new exponent. And so there's our integral, and we're going to evaluate that from negative 2 to 1. So that would be our setup for moving forward. So we start out by, remember we always do top minus the bottom, so I'm going to plug in my 1 first. So 1 to the 4th is obviously 1, but I guess I'll just show the setup because this is what you'd want to do on a test. So you would show your setup like this. So always good to show that setup and then do the work from there. So a little cleanup on this, that would just be 1/4 for the first term. And then this guy's going to come out to be 16, positive 16 over 4, which is 4. So 1/4 minus 4 would just be negative 3 3/4. So you can write that as a mixed number or a improper fraction, really doesn't matter. So jumping over to number 7. So here's where we're involving kind of like the chain rule idea with something like this. So you do now have an interior function, so that's really important. You could just FOIL this out. You could do 2 plus 5x times 2 plus 5x and turn it into just a singular function like that. I'm going to show you 2 ways of doing this. I'll do it real quick in case you're interested in seeing both methods. But if I were to FOIL this piece out, which a lot of students would do, so if we FOIL this out, we would have that plus 20x plus 25x squared. And so that would be the way we would view that function. And now if I go through my integral process, again, think of that as 4x to the 0 initially. So it's going to become 4x to the first over 1. This becomes 20x squared over 2, so 10x squared. And then this would become 25x to the third over 3, and that doesn't reduce, so I'll just write that out. So that would be my integral, and now I can then evaluate it from 4 to 2. So now if I plug in my 4 and then plug in my 2 and then subtract those results, I would get my answer. One thing to keep in mind on this is the subtraction comes at the end, so you got to be careful with the use of your negative signs. That can be an issue on a test for sure. So I'm just going to set it up and then I'll let you solve it. It's really not hard to solve from here, but if I sub in my 4 for x first, so we're going to get the setup that looks like this. There we go. All right, so there you are plugging in the 4, and then minus, and now you're going to plug in the 2. So remember, you got to separate those groups with that negative and use a proper use of parentheses just to make sure that everything ends up correctly at the end. So now if you just plugged in your 2, and then you can just do a little cleanup from here. I'm just going to write out the setup. So there's the full setup that we would have. So again, you would evaluate all this set of parentheses first and get a value. Then do this set of parentheses and get a value, and then subtract at the end. So here's the other way that we can do something like this. With kind of like the chain rule idea, is if we do our standard rules where we do, let's increase the exponent by 1, and then divide by the new exponent. And then now you, remember when you do a derivative, you multiply by the derivative of the interior function, which would mean you were multiplying by 5. But when an integral, you do the opposite, and you divide by the derivative of the interior function. So if I divide by 5, which is going to put him down on bottom, then the other way we could have written this integral would have been this way. And that's going to become the most common way that we would use because it's so much quicker than doing this process that we did over on the other side. So this will be the way that we're going to get used to doing it with the chain rule idea. But the one thing that I just super important in this process is anytime you do chain rule, whether it's doing a derivative or an integral, you have to remember to take into account the interior function. So if it's an integral, you got to divide by the interior derivative of the interior function. If it's a derivative, you got to multiply by the derivative of the interior function. But never forget that step. That's a really common mistake made in this chapter. So moving over to number 8. Kind of more of the same here. So I'm going to take my x to the 3/2. I'm going to increase the exponent by 1. So if I added 1 to 3/2, that would push me up to 5/2. And then I divide by, so there's two ways you could say this. I'm going to also divide by 5/2, right? But obviously in the past, typically we don't divide by a fraction. Instead, we multiply by the reciprocal. So instead of dividing by 5/2, you could say I am multiplying by 2/5. So we could write that either way. Either way is correct. Just two different ways of looking at it. This is probably the more comfortable setup that we would use. But anyway, I would now evaluate that from 9 to 4. So as always, we do top minus the bottom. So now you would just plug in your 9, plug in your 4. All that's going to go in your calculator. Just subtract your results. One thing I would keep in mind on this is if this was a no calculator situation, so if I had my 9 to the 5/2, and then we're going to do this side. Let me just set it up. So if this were a no calculator situation, how do you deal with a fraction exponent? Remember what that means is the denominator is the root. So this is a square root, and then this is the exponent. So I would square root my 9, which is 3, and then I would raise my 3 to the 5th power, and then multiply that by 2/5. So definitely doable by hand if we needed to. Moving on to number 9. So notice on this one we now have an indefinite integral for number 9. We're not evaluating it for any specific set of numbers. So we just find the integral, and then we got to throw in the plus c at the end of that. So again, for number 9, remember you got two options for this. I could FOIL that out and just do the 5 minus 4x times 5 minus 4x and take the same approach that we took up above when we did number 7. That's an option, and that would be accepted. But really the more efficient way of doing this and the way that we want to get used to it is if we take our 5 minus 4x, increase the exponent, divide by the new exponent, and now here's where we say, okay, but I also have this interior function where the derivative is negative 4. Since we are doing an integral, the rule is to divide by the derivative of the interior function. So it goes on bottom. And so now I got my kind of final answer going on right here. One thing you can't forget is your plus c, because it's an indefinite integral, so don't forget to keep that as part of your answer. That's important. Moving on, number 10. So with this, these are really popular IB style of questions. Is doing it with these, in a lot of ways, it's because they're kind of forcing you to not be able to use a calculator. What we did with definite integrals up above, these can be put into a calculator. So this is their way of sort of forcing students to sort of not use a calculator and make sure that you're working through a problem like this. So trying to find the value for k. K is an element of the real number system. So of course they're going to say that. That's just kind of common notation. So in this case, remember, we're just going to stick with the same process. I first want to put this into friendlier terms. So I want to see that as x to the negative 1/2 power. And then I'm going to go through my integral process where I add 1 to the exponent. So if I add 1 to negative 1/2, that brings me up to positive 1/2. Divide by the derivative, or sorry, divide by the new exponent. So if I divide by 1/2, that is the same thing as multiplying by 2. So there is our integral, and we're now going to evaluate that from 12 to k, and we already know the answer is this. I'm seeing what they got on that right side. I think that's supposed to say the square root of 3 times 2, so I don't know why that wasn't just written as 2 rad 3, but I'm pretty sure that's the way it's supposed to look. Otherwise, that's just sort of an odd way of placing that in there. It almost looks like the square root of 3 times 0.2 for some reason, but anyway, so going from here, if we start throwing in some information, so I got my 12 that's going to go in there, so I got 2 times 12 to the 1/2, which is the same thing as the square root of 12, minus 2 times k to the 1/2, or the square root of k, and it looks like that's supposed to equal 2 rad 3. So there's our setup for that one. So a little cleanup. One thing you could do right off the bat is just divide everything by 2. So that's not a bad idea. So let me do that. So I got my square root of 12 minus my square root of k, and that equals the square root of 3. So I divided out the 2. So just a little cleanup on this one. This would help if I could see this as 2 rad 3 instead of the square root of 12. I'm going to need to do that in order to be able to combine that with my square root of 3 that we have over there on the right side. So if I, let me just kind of do a little switch around here. So I'm going to add the square root of k over to the right, subtract my 1 rad 3 from the left. So on the left side, if I did 2 rad 3 minus 1 rad 3, that just brings me down to 1 rad 3. And I moved this guy over to the right side. So now if I square both sides, I can see that 3 was my k value. Moving on, last one we're going to show here is number 19. So going all the way down to the bottom. So we got a particle with a velocity function with a time from 0 to 25 in seconds. So find the total distance traveled. So right off the bat, we have to notice that, remember, position or distance is like the original function. Velocity is the derivative of distance. And then acceleration would be the derivative of velocity. So if we have a velocity function and I'm trying to get to the distance function, that means I need to integrate this to get up to the distance function. So taking my function that we have right here, let's put that into some friendlier terms. So let's call that t to the 1/2 minus t. So that is our velocity function. So we want to integrate that in order to get our distance function. And then we're going to evaluate it from 16 to 4. So just doing the kind of the typical integral process on this, where we add 1 to our exponent, so it's going to become 3 halves, and then I would then divide by 3 halves, which is the same thing as multiplying by 2/3. And then my t becomes t to the 2nd over 2. And then let's do a little cleanup on that before we start thinking about evaluating it. So from here, 2/3 times 5, so let's just call that 10/3. T to the 3 halves. And then divided by 2, let me just call that 1/2 t squared. Same thing. Doesn't matter if you leave it that way or that way, it's really the same thing. So, but that's, I now have the kind of the most appropriate or simplified version of the integral. So now we want to evaluate that from 16 to 4. And so we're just back to kind of plug in some numbers and do a little cleanup. Just remember, you want to subtract last. So as you plug in your 16, and you got your 10/3, 16 to the 3 halves, minus 1/2 16 squared. So that's the entire first part. Then you got your subtraction, and now you plug in your 4. So use proper use of parentheses or brackets to really give some clarity to yourself as to just the proper use of signs. So I'm going to run out of room here over on the right side, but I'll kind of take it as far as I can. So I'm putting in my 4 to the 3 halves minus my 1/2 4 squared. That's where my brackets will end. So again, I should be getting a value for each set of brackets, and then I would subtract those at the end. And if we did that correctly, we should be good from there.